special trigonometric function. I have discussed two more classes before. Now, if you watch the uh, concept in this case, you will find that you will be getting the idea of one typical type. The type is typical type. Trigonometric function typical type is, I have discussed like dx by a plus b cos square x, or a dx by a plus b sin square x. Not only that, we have discussed dx by a cos square x plus sin square x also. In these cases, we have divided by dividing numerator and denominator, both by cos square x. I have divided by cos square x. You can do sin square x also, but it will be easier for doing that. Tan square x will come, sec square x and tan square x will come, and then you can solve. This is the type I have discussed before. Now, if I take another example that is very similar, another one. If I just adjust this question, I am changing the question here. It is not square. Just to look at the idea, it is not square. Not square. Then what we'll do? This is the next type. This type I am wanting to discuss. Today's first topic. So here what I'll do means what I suggest you to do. Write cos x as cos square x by 2 minus sin square x by 2. You write cos x as cos square x by 2 by minus sin square x by 2. And sin x as, this is submultiple. It is a bit difficult sometimes for those who are not comfortable with trigonometry, but you just remember this idea. I'll prepare a trigonometric list of formula and I'll share with you next discussion what are the formulas we need in trigonometric integration. Cos square x by 2 minus sin square x by 2. You put that, then divide after simplification, of course, by cos square x by 2. Divide numerator and denominator both. Numerator and denominator both. Both numerator and denominator by cos square x by 2. So what is the concept? You have to do by division. Exactly we have done before, but cos square x by 2. Now take the example. Let us take an example. So the similar example we can have in other cases also. I am showing one, dx by 3 plus 2 cos x. You have to integrate. Now it can be 3 plus 2 sin x. It can be 3 sin x plus 2 cos x. Same rule. What will be the rule? Dx by 3 plus 2 cos x, I am writing as cos square x by 2 minus sin square x by 2. That means instead of cos x, we are writing the submultiple formula. Now, dx by 3 plus 2 cos square x by 2 minus 3 sin square x by 2. Sorry, 2 sin square x by 2. Should be 2. 2 sin square x by 2. Fine. Now change the cos sin square x by 2. We are changing this, no simplification. We are changing means dividing, not changing. I told you, after putting this formula of cos x or sin x, dividing numerator and denominator both by cos square x by 2. So we'll divide it by cos square x by 2. So it will be dx by cos square x by 2 in the numerator, whole by 3 by cos square x by 2 plus 2 cos square x by 2 by cos square x by 2 will be cancelled. Cos square x by 2 will be cancelled. Minus 3 sin square x by 2 by cos square x by 2. So this is the concept of this type of integration. 3 plus 2 cos x, writing cos square x by 2 minus sin square x by 2 by for cos x, and then now dividing by cos square x by 2. So what you are getting, dx, this is becoming sec square x by 2, because cos square x by 2 reciprocal is sec. Reciprocal of cos x sec. This will be also sec square x by 2. This is plus 2 minus 3, sorry, not 3. I'm sorry, there is a mistake here. I'm not saying mistake. That should be 2. Here also I made a mistake. Here it should be 2. I made a mistake. So it will be 2. So this is 2. So once more, let us focus on this question from the beginning. What you are finding from the beginning, 3 plus 2 cos x, instead of cos x you write cos square x by 2 minus sin square x by 2. Proceeding with the simplification, and then dividing by numerator and denominator by cos square x by 2 to get sec square x by 2 dx in the numerator, and the denominator is 3 cos sec square x by 2 plus 2. There is a 2 here. 2 minus 2 cos tan square x by 2. Now write sec square x by 2, the denominator. Numerator will be as it is, sec square x by 2 dx. And the denominator is 3 sec square x by 2 is tan square x by 2 plus 1. Sec square theta is cos tan square theta plus 1. Sec square theta is tan square theta plus 1. Minus 2 tan square x by 2. So now we will open the bracket. If I open the bracket, what we will be finding? Sec square x by 2 dx by, bracket opened, 3 tan square x by 2 plus 3 plus 2 minus 2 tan square x by 2. So what you are finding, that result is now, the question is now sec square x by 2 dx whole by only tan square x by 2 plus 5. Now let z is equal to tan x by 2. So this is the method. In all these problems, dz will be sec square x by 2 for tan x into half for x by 2 dx. This half is coming because of this x by 2. X by 2 will be half. So you are getting 2 dz. This half will be taken on the left side, is equal to sec square x by 2 dx. So you are getting in the numerator, instead of dx, but sec square x by 2 dx, we will write 2 dz, and the denominator is z square plus 5. So this is 2 outside, dz by standard integral z square plus root 5 square. The formula, tan inverse. What is the formula? Tan inverse. So that will be 2 1 by a. 1 by a is 1 by root 5. Tan inverse z by a is root 5 plus c. So your answer is 2 by root 5 into tan inverse tan x by 2, because z is x by 2 by root 5. So this is your result. So if you look at this problem again, the problem will be dx by 3 cos x, 3 plus 2 cos x. Instead of that, it can be 2 sin x. So we'll write same 2 sin x by 2 cos x by 2. Then we will divide by cos square x by 2 to get sec square x by 2 in the numerator. And then we are getting tan x by 2, and then substituting and simplifying, we will get the standard formula as this. So this is one of the very important topics. So we have discussed some type of trigonometric integration. Now the inverse trigonometric function, how we will solve. I suggest always take the inverse as theta. Mane sin inverse x, if you see, take theta. Cos inverse x, take that as theta. Tan inverse x, take that as theta. So that means if it is sin inverse x is theta, then it will be sin theta as x. If it is cos inverse x as theta, then it will be cos theta as x. If it is tan inverse x as theta, then tan theta is x. One thing you remember, there is a triangular concept if it is theta, when we say this is base, this is perpendicular, this is hypotenuse. So that hypotenuse is root over h square p square plus b square. Perpendicular square plus base square. So always we remember this kind of diagram to get the values of the trigonometric function. Let us take the example of inverse trigonometry. But before that, one more thought I would like to share, that is by parts, integration by parts, integration by parts, that is integration by parts, product rule, integration for product rule. Product rule means two functions are different and we have a product rule for integration, and that is uv. uv means two functions u and v dx will be u outside v dx second function minus derivative of u into integration of v, then whole integration. Second part by part. First part is u, then integration of v minus derivative of u into integration of v, the whole of integration. Now let us take the example. Some example I am doing. Like integrate sine inverse x dx. So I take always, let theta is equal to sine inverse x. Always I take that. Therefore, x is sine theta, because if you reverse the function in that sense, then x will be sine theta. Therefore, dx, the derivative will be cos theta. Sine theta derivative is cos theta into d theta. Now come back to the problem. Instead of sine inverse x, we will write theta. And instead of dx, we will write cos theta d theta. So now it is uv, that is product rule, or by parts we can say. Ilet, we know that ilet, inverse, log, algebra, trigonometric, and in exponential. Here it is at. Algebra is theta and trigonometry is cos theta. So we will put a outside, that means theta outside, cos theta integration d theta minus a theta derivative d theta, derivative of theta with respect to theta, into cos theta d theta. This whole portion is again integrated d theta, second part. So first part is theta cos theta, integration is theta, cos theta integration is minus sin theta, minus theta derivative is 1, so it is minus sin theta for the second part, that is to be integrated. So this minus sign will be taken outside, it is minus theta sin theta plus only sin theta d theta. Now integration of sin theta we know, that is cos theta. So we have the answer as minus theta sin theta plus cos theta is the answer, because sin theta integration is cos theta. We are not getting the final answer from here because we have said x is equal to sin theta. That means theta is equal to sin inverse x we have taken. Now we have the question of what is cos theta. Cos theta is sin square theta plus cos square theta is 1. Sin square theta plus cos square theta is 1. So cos theta will be 1 minus sin square theta. Cos theta is 1 minus sin square theta root over 1 minus x square. If you cannot understand, you can draw the diagram also. Sin theta is perpendicular by hypotenuse, so x by 1. So this will be, base will be 1 minus x square, perpendicular square subtracted from hypotenuse square. So if it is theta, then cos theta will be base by hypotenuse. Base is 1 minus x square, so cos theta is 1 minus x square under root by 1. So your answer will be, put it there. Theta is sin inverse x. It is x, sorry, I made a mistake here. That is x. It should be x. So there's a small mistake. Sin inverse x and sin theta is x. So it is minus sin inverse x plus x into x plus root over 1 minus x square plus. So this is the answer. We are coming back to x. If you cannot, then put sin inverse x as theta everywhere. You can get the answer. Not a very good looking answer, but it's okay. So this is the first type, one question of this kind. Next we can do like another question, that is x tan inverse x dx. So we'll take what? The same idea. Let theta is equal to tan inverse x, since the problem is in terms of tan. So x is tan theta. Therefore, dx, the derivative differential, that is sec square theta d theta. So come back to the problem. Here it will be, this x is tan theta. Tan inverse x is theta. And dx is sec square theta d theta. Now we will be concentrating in this way. Theta separate, tan theta into sec square theta d theta. This part is together as a trigonometry. So again, by parts, I think we know that first we will be doing the algebra for outside. Outside means that u is outside, v is tan theta sec square theta, this integration together, minus theta derivative and integration of tan theta sec square theta. This is something we should take care. And then whole this integration with respect to theta again. So last d theta. So two times we are writing d theta. One for the first function that is inside here into. This is into. Now if I do this integration here, I'm showing this integration separately. Tan theta sec square theta d theta, I am showing this separately so that we can understand better. You can do that also during the exam, that you can write this way. Let z is equal to tan theta, therefore derivative of z, that is dz by d theta will come, and dz will be sec square theta d theta. So if you look at the problem, tan theta is z and sec square theta d theta is dz. Tan theta is z and sec square theta d theta is dz. So your answer will be z square by 2, which is tan square theta by 2. So we come back to the integration again. Our integration was originally it was theta, then tan square theta by 2, because it is already shown first function integrated separately, minus tan square theta by 2 d theta, because what is the thought, this first function in d theta by d theta, one derivative of theta is 1, and then tan theta sec square theta, tan theta sec square theta, just now I have shown tan square theta by 2, and that was 1 here. I don't need to write 1, so it is half theta tan square theta here minus half. Tan square theta is sec square theta minus 1, because we have to integrate tan square theta, converting that tan square theta to sec square theta. So our idea, our calculation will be now half tan theta tan square theta minus half sec square theta, integration is tan theta. This minus and this minus is plus, half theta plus c. So now come back to what was the substitution. Our substitution was theta was tan inverse x and tan theta was x. So let us put there, half theta is tan inverse x and tan square theta is x square. So that is the first part, minus half tan theta is your x, plus half theta, that is tan inverse x. So this is your answer of this type of problem. But you can do in a different form. Now I can show one more question, like if it is sine inverse x whole square dx, or let it be cos square x. We can do that cos square. Instead of sine inverse x, it is say cos inverse x whole square. So I'll take let theta is equal to cos inverse x. Fine. Therefore cos theta is x. So minus sine theta d theta is dx. So coming back to the question, it will become theta square, because cos inverse x is theta. Dx is minus sine theta d theta. Okay. So we'll take outside, which one? Minus sine. And theta square also outside, sine theta is there, d theta, minus, it will become plus, because theta square and minus sign is this, minus sign will make it plus. Theta square derivative dd theta of theta square, this is the first function, and then sine theta d theta, this is the second function, is this, by parts. So all we need to do in the case of inverse, we have to do this idea. Which idea? that we have to use your trigonometric concept. Theta square sine theta integration is minus cos theta plus theta square derivative is 2 theta, and this is minus cos theta. Here again this by parts will come, theta cos theta. So your answer is coming here is plus theta square cos theta, because minus minus plus it will become minus. It will become minus. So it is minus here, minus 2 outside theta cos theta d theta. Once more by parts. So it will become theta square cos theta minus 2. Theta is outside cos theta integration d theta minus by parts. Again we are doing by parts. Derivative of theta, that will be 1 into cos theta integration. Cos theta integration will do, and d theta for this integration, and another d theta for the second part integration. So you're getting here theta square cos theta minus 2 bracket theta cos theta integration is sin theta minus this theta is 1, only sin theta comes d theta. So we will be completing the problem now. This is theta square. This is theta square cos theta, trigonometric point of view. 2 theta sin theta. 2 theta sin theta plus 2 sin theta integration is minus cos theta plus c. So now you will be putting the value. Theta square will be cos inverse x whole square, because theta was cos inverse x, into x because cos theta was x, into theta cos inverse x. Now what about sin in theta? Sin theta will be 1 minus 1. This will be because cos theta is x. Then sin theta will be 1 minus x square under root, because sin square theta. Or you can do this way. This is x, this is 1, this will be 1 minus x square. So it automatically sin theta will be perpendicular by hypotenuse. Minus minus plus minus 2x, cos theta is x plus c. So this is the answer of this question. So if you look at the question, cos inverse x whole square, you take theta as cos inverse x, then proceed with by parts. 2 times we have doing by parts and solving that way. Now another problem I would like to do, that is sin inverse x into x whole by root over 1 minus x square. This type of problem. Same method. Let theta is equal to sin inverse x. So sin theta is your x. Therefore dx is cos theta d theta. Therefore you are getting now x is sin theta. Sin inverse x is theta. Dx is cos theta d theta. And the denominator is 1 minus x sin x square, 1 minus sin square theta. So you are getting the result in this way. This is becoming sin theta theta cos theta d theta by cos theta. So cos theta cancelled out. Therefore you are getting only theta sin theta d theta. That is not very difficult by parts. Theta outside, sin theta integration, which will be minus cos theta d theta minus derivative of theta is 1, sin theta integration, which will do, and again another d theta for the second part. So you are getting the result as theta into sin theta is minus cos theta minus theta is 1, that will be minus cos theta d theta. So ultimately you are getting minus theta cos theta plus sin theta. Cos theta integration is sin theta plus c. So what was the substitution? Sin theta was x, so it will be minus sin inverse x into root over 1 minus x square, because it is cos theta. So your answer is plus root sin theta is x plus c. So this is your answer. So this way we can integrate that inverse problems, or many problems can be there. Always we use by parts, but I have suggested to use first you do the idea of that one. theta substitution.